Before it even arrived, I built a custom rolling cart for my Prusa XL. It's the only surface it's ever been on. Now, I've built the same for the CoreXY. Welcome to BarrittWorks. So, what led me to put my printers on rolling carts when many people go the opposite direction, looking for particularly solid surfaces, even adding things like concrete pavers for stability? A little background. I share a small office studio with these printers and an e-dry cabinet, along with other equipment that comes and goes. I needed a way to isolate everything that makes noise or pollutes. And so, initially, the printer closet was born, with all such machines tucked in behind solid accordion doors with weather stripping, so all the gaps are sealed. At first, the closet held one printer, an open frame bed slinger without an enclosure. So isolating was the easiest way to avoid breathing what it produced, as well as blocking the noise. Even sealed up, the closet never went above the high 80s Fahrenheit, warm enough but not really problematic. And when I opened the doors, the fumes were noticeable, but in general, this simple solution worked. Okay, skip forward. By the time the Prusa XL arrived, I had planned a new approach to managing air quality, though still depending on the closet to isolate sound. I printed the excellent NX enclosure from Voxel 3D NL, look for it on printables.com, ordering the plexiglass kit to go along with it, and modified its top with a custom magnetically attached 4-inch 100mm exhaust port. I installed an AC Infinity duct fan in the closet to pull air gently from the XL via flexible tubing and route it out through the attic, creating a slight negative pressure in the enclosure and successfully venting everything outside. So I have a good air quality monitor always running in the room. And more informally, at the beginning, I checked this system by burning incense inside the enclosure while I stood right next to it. There was no hint of odor from it. So far so good. But the printer closet shares a back wall with another room that at times needs absolute quiet, and some slight printer sound makes it through. So the plot thickened. Enter the rolling carts. These carts allow me to easily move printers temporarily out of the closet without interrupting their ongoing prints. The XL has an auto spooling power cord, which keeps it powered as it moves. The CoreXY, at the moment, just drags its extension cord because I'm having trouble finding a spool for it. I have seen no discernible effects to print quality from gently moving the XL while it's printing, which I've been doing now a couple of times a month during its daily printing for over 2 years. So to continue to have access to the out-of-building exhaust system that's in the closet, I created a 4-inch pass-through in the wall and installed a Y valve using the same quick magnetic fittings, so it is easy to reconnect the printers once they are in the office. This system has been working well. Regardless of how much printing is happening in the closet, it's quiet in the office, just feet away, and the air is clean. And if prints are running when the other room has more of a need for quiet than the office does, I roll the printers out, close the closet doors, creating a highly effective buffer. So the e-dry cabinet creates a bit of fan noise during its circulation phase. When it arrived, therefore, it went into the closet as well. It went on the floor, sitting under the bolted down shelf that the CoreXY was on originally. So the CoreXY cart I just built mostly follows the same design as the XL cart, even matching the top dimensions, so the XL and CoreXY can be swapped or some other mid to large format printer could use them. The new cart is different in being slightly taller and more efficient with the vertical space on the lower shelf by turning the two upper cross pieces 90 degrees in order to fit the e-dry below. I don't need the e-dry to roll out of the closet, but there's no other place to put it, so it comes along for the ride. The lower shelf is also deep enough for another AC Infinity T3 Thermoforge heater to go behind the e-dry in case I decide to actively heat the CoreXY in the same way I do the XL. Both carts are constructed from 2x4s planed down to mimic the crisp, clean look and function of the poplar stock I used to buy from my local lumberyard before they, sadly, closed. So in the absence of easy access to this wonderful stock for quick, functional, and expensive furniture that also looks good, I tweak regular pine 2x4s to mimic it. I take roughly 1/8 of an inch off of each surface, bringing the stock down to exactly 1 1/4 by 3 1/4 inches. I do this to carefully select the 2x4s that are particularly straight and clear of knots. The result looks almost as good as the poplar and is easy to build with. The straight runs with crisp milled corners and precise dimensions remove much of the normal variability of building a 2x4 frame. It even begins to feel a bit like building with 80/20 aluminum extrusions, which I would use if that wasn't so much more expensive. Keeping with the somewhat erector set-like approach, I use Kreg pocket screw joints that are not backed up with glue. I want the freedom to disassemble and change elements if needed. Also, I've never had a pocket screw joint loosen in many years of using them, so I've come to trust them. These joints are quick and dependable, but a bit difficult sometimes to make sure they come together precisely aligned. I laid out the design in CAD and printed the plans, including a visual cut plan for both the framing pieces and the 3/4 inch plywood for the surfaces. Following the cut plan and the printed design kept the build process in the shop quick and easy. Making the most efficient use of the source stock pretty much required not cutting the same length pieces one after the other. Instead, each initial piece of stock, after the planing stage, was cut into a variety of varying length frame pieces. I used the Incra positioner with the table fence attached to make this easy and accurate. I call it my table saw fence, but it is frequently deployed on the Omni table in a variety of other configurations, so I'll use Incra's positioner term instead. So once the positioner is registered to the chop saw, I can cut precise parts repeatedly in varying lengths, one after the other, mechanically locking these to lengths with 1/32 inch precision, or even finer if I use the positioner's fine adjustment knob, using the internal tapes to set the lengths, and therefore not resorting to stop blocks or the like to repeat these cuts. I easily end up with stacked sets of various lengths of framing pieces ready for assembly that are identical as far as my tapes or my fingers can discern. While drilling the Kreg pocket screw holes, I use the in-table vacuum cyclone system rather than the shop's 4-inch system, as its 1¼ inch hose is much easier to manage with small devices, and it's immediately accessible in the table. Assembling the frame required careful clamping to guarantee precise joints, but was otherwise erector set simple. I use a pocket hole clamp that inserts into one of the pocket screw recesses to hold parts in place, and insert a screw into the other hole, where each joint has 2 paired screws. Then pull the clamp out of the first and put in the second screw. This still requires some care, and sometimes additional conventional clamps, and even then can go a bit wrong, as it did on this build in one instance. More about that in a moment. After the frame was done, I switched the table back to table saw mode and cut a scrap piece of 13-ply Baltic birch plywood to size for the upper surface, then for the 2 wings, and then I found a smaller than desired piece, but workable, for the lower shelf. Years ago, when I built the XL cart, I created pocket screw holes on the inside of the upper frame that faced up to attach the upper surface invisibly from below. I didn't take the time to do this for the CoreXY cart, though I could add it later if I really wanted it. Instead, I quickly attached the surfaces with 1½ inch brads. I expect this will hold indefinitely, and I certainly was glad not to work up another set of slightly non-standard pocket screw holes. Besides, it feels good to drive finish nails, old school, by hand, with a hammer, on such an easy surface. In doing that, I discovered that the upper cross pieces of the frame were a bit proud of the vertical pieces. So I didn't want the weight of the printer to be transferred to the crosspiece joints. I had to correct this. I could either trim the pieces flush in place, putting the frame on its side and running them by the table saw, or I could reattach the cross pieces flipped 180 degrees so they cut new screw paths, and be more careful with the clamping to make sure they came together perfectly aligned, which is what I did. For now, I only installed one of the 8-inch wings, the fold-out top surface extensions, as I thought the other one would not fit where the cart was going to sit in the closet. I've since discovered that it will in its collapsed position, so I may install this second wing later. Last, the decision about casters, whether to install them or not. I use wide, double-wheeled casters in the office that roll well, with a heavy load even, on the tight carpet, and also help to avoid denting where they normally sit on the carpet protectors. This is what I have on the XL cart, as well as what I have on my main desk, and I had a set of them in hand for the new cart. But they would add roughly 4 inches to the height, and I wasn't sure if that was going to be okay. I considered installing carpet sliders instead, which would keep the height down and would still be movable, but with a bit more difficulty, and would be more stable. But in the end, I went with the casters, and as it turns out, the height is not a problem, and I even prefer it, particularly in getting to the E-dry a bit more easily. I adjusted the closet shelves that were behind the CoreXY, where it sits, to fit this new height, which will of course change again when the index arrives and the top hat gets installed. That's a part of that update. As I mentioned, I reconfigured the shelving in the closet around the CoreXY when I put it on the cart, particularly the shelf just behind and near the top level with the printer, because I've already switched to a top feed port for the current one-head CoreXY configuration, and I will continue with a from-behind filament feed once I install the index upgrade. I've long had a similar top feed on the XL for when I print with flexible filament. I thoroughly appreciated the easier feeding from above on both printers. I'm going to continue to use and refine this approach, though it's a bit harder to adapt to multiple printheads on the XL, rather than hanging a veritable Christmas tree of exposed spools all around both printers. Because these carts are on casters and are not solidly attached to the floor or wall, though they are themselves a solid, rigid structure, they do move, let's call it wiggle, when the printer is making particularly fast movements. As it turns out, printing from these wiggling platforms has not been a problem, despite it seeming wrong to see the printer move, perhaps because relative to itself, it isn't. What I mean is that the printer nozzle is stable relative to the print bed because both are carried by the same rigid, solid structure, which is what's moving overall. Regardless, print quality has not suffered on either printer. As an aside, I've had the XL on the cart from the very beginning, but the CoreXY had 10 months of printing on a solid shelf with zero movement before this transition, and I have not found any difference in its output, including with tall prints. The CoreXY, by the way, has Hulu feet installed. The XL is on solid printed feet, though double the height of the stock rubber feet, and with additional feet added at the back where most of the printer's weight is. I have Hulu feet and adapters for the XL, but I haven't installed them yet, and at some point I may install them and test that. Hi, it's me from the editing future. I recognize that highly unconstrained carts for printers might be slightly surprising, as there has been so much attention on putting printers on solid, rigid, high-mass surfaces. My introduction to all that was in the context of mitigating and isolating vibration. However, since input shaping and phase stepping has substantially fixed resonance-induced and stepper motor vibration and the attendant print artifacts and noise that go along with them, things have changed. Mitigating vibration, while still important, is much less of an out-of-control and pressing issue than it was just a few years ago. So, why do we still seek solid surfaces for our printers? Could there be a slight advantage, even, to not imparting distorting forces on the printing frames by letting the entire structure move in reaction to rapid printhead movements? The happenstance of my printers still working perfectly on such surfaces as they rock and roll, actually primarily only translating horizontally on X and Y, got me thinking, sure, I'm glad to simply get away with this, because I need my printers on rolling carts for other reasons. But why does it still work so well? Why have I seen no difference in print quality or not seen any uptick in failures? So, I'm considering doing a full video exploring this. Let me know in the comments if this might be worthwhile for you. Right or wrong, I'd like to explore what I think has been going on with my printers on these carts, with and without hula feet, and what it means for printer frame flexing and overall print quality in general. Is there any reason to reconsider our predilection for heavy, solid surfaces for our printers? Or at least to not strenuously avoid unconstrained surfaces when they serve some other pressing need or are simply much more convenient? Because I gotta tell you, beyond the noise isolation, my original motivation, it's been great being able to simply spin the printers around when I need to get to the back for some maintenance or an upgrade or whatever else. Okay, back to the present. So, drop a note in the comments if you have used or experimented with mobile carts for your printers, or if you have questions or ideas. And if you haven't yet, please subscribe and like. And thanks for watching.